Okay. So, hello everyone. I am Madhuri Bhattacharya, a Prime Minister Research Fellow in Department of Chemistry, IIT Madras. I welcome you all in this NPTEL online course on Industrial Inorganic Chemistry, which has been taught by Professor Debashish Rai from Department of Chemistry, IIT Kharagpur. So here we are discussing regarding some important inorganic materials, their purification, their production and utilization. So these are my details and you can contact me for any further clarification or your queries over my email IDs. So far we have discussed regarding some materials like nitrogen, phosphorus, halogen materials and some fertilizer. So today we will discuss regarding some more materials. So the first question is about bleaching powder. The chemical formula of bleaching powder is, the correct answer will be calcium hypochlorite chloride. Okay, CaOClCl. So calcium hypochlorite, actually CaOClCl. Its general formula is written by this one. Then moving to the next question, which one among the following is the correct method for preparation of alkali bromates? So electrochemical reduction of HBr or oxidation or reduction of NaBr or oxidation of NaBr. So for preparation of alkali bromates, the option will be, correct answer is electrochemical oxidation of NaBr. The reaction is as follows, where alkali bromates are generally produced during electrochemical oxidation of sodium bromide. Hydrogen gas is evolved in this process and the chemical reaction is sodium bromide hydrolysis by H2O and then sodium bromate NaBrO3 followed by hydrogen gas production. Okay. Then the reaction of iodine, sulfur dioxide along with water will give which product? Products are option number A, hydrogen iodide along with sulfuric acid. So this is actually Bunsen reaction. Bunsen reaction is a chemical reaction that describes water, sulfur dioxide and iodine reacting to form sulfuric acid and hydrogen iodide. This reaction is the first step in the sulfur iodine cycle to produce hydrogen actually. Okay, so after that the products separate into two aqueous layers. These products both are actually liquid and since water we are using in the reaction medium, so this will be denoted as in aqueous phase, and both being liquid products but having different densities, they will separate out as two different aqueous phases, with sulfuric acid floating on the top and a mixture of hydrogen iodide and unreacted iodine on the bottom due to higher density. Okay, moving to the next question. Iodine is necessary for the synthesis of which of the following hormone? And adrenaline, auxin, thyroxine, and insulin. So correct answer will be thyroxine. As we all know, iodine is a trace element present in our body and it is necessary and a limiting substrate for thyroid gland hormone synthesis. It is an essential element that enables the thyroid gland to produce thyroid hormones like thyroxine and triiodothyronine. Okay. Then ammonium phosphate. This is one fertilizer, but what kind of fertilizer? Nitrogenous, phosphate, complex or mixed? So this is actually a mixed fertilizer. Mixed fertilizers are those fertilizers which contains more than one element like nitrogen, phosphorus, potassium, mixture of elements it contains, and it is very much essential for promoting plants growth and high crop yields. These are obtained by thoroughly mixing the ingredients either manually or mechanically. So here ammonium phosphate is a mixed fertilizer. This is obtained by the reaction of orthophosphoric acid and ammonia. So simple acid base reaction only, like simple acid base reaction, ammonium phosphate. NH4 whole 3 PO4. This is produced by simple acid base reaction. 3NH3 plus H3PO4 NH4 whole 3 PO4. Right? So this is actually mixed fertilizer. Since contains nitrogen, phosphorus, both structure will be okay. So this is the ammonium phosphate. Then which of the following is not a reactant of carbonitric process? So not a reactant of carbonitric process. Option will be H2SO4. This is not used because in carbonitric process this is a complex reaction involving calcium phosphate, ammonia, nitric acid and carbon dioxide and water, but not involving any sulfuric acid. So the correct option will be sulfuric acid is not involved in the reaction of carbonitric process. Then what is the molecular weight of urea in gram per mole? So urea, as we all know, what is the structure? The molecular formula. To calculate the molecular weight, we need to know the molecular formula, right? Molecular formula of urea. Urea is this one, NH2 whole 2 CO, or that is, if we write a molecular formula, so N4, not N4, N2 H4 CO, right? Then molecular weight 14. Nitrogen, each nitrogen will contribute to 14. 14 into 2 plus 1 into 4 plus 12 plus 16. So 28 plus 4 plus 12 plus 16. So total 28 and 12 will be 40 plus 16 plus 4, 20, so 60. gram per mole, right? So molecular weight of urea is 60 gram per mole. Okay. Then for which of the mentioned does urea serve the purpose? Fertilizer, formaldehyde, resin, melamine, and all of the above. So option will be all of the above. The correct answer is because urea is used as a solid fertilizer. 53% of the urea is used as a solid fertilizer. Liquid fertilizer also 31%. Now other miscellaneous applications such as animal feed, formaldehyde, resin, melamine, and adhesives. It has multiple applications. Then which fertilizer is also known as muriate of potash? Potassium nitrate, potassium chloride, potassium sulfate, or potassium magnesium sulfate. So the correct option is potassium chloride because muriate is derived from the term muriatic acid, which is a common name of hydrochloric acid only. So over 90% of all processed potassium is consumed as fertilizer, and at least 78% of the potassium salts consumed worldwide is muriate of potash. So muriate of potash means similar kind of salt of potassium as hydrochloric acid, so that is potassium chloride, KCl. Then urea reacts with NOx type of pollutants to produce NH3H2O, N2HNO3, N2H2 or NH3N2. Option correct answer will be N2 and H2O. So urea reacts with NOx type of pollutants in presence of air and converting them into N2 and H2. So urea reduces severe pollutants like NOx type into non-pollutants like nitrogen and moisture molecules. So the reaction involves are ammonia production by urea decomposition. So urea means at a temperature greater than 150 degrees centigrade, which is the decomposition temperature of urea. It will be decomposed to produce NH3 gaseous plus H NCO. Then this will be adsorbed on some catalyst, and along with this H2 also be adsorbed. Then it will produce NH3 remain as adsorbed only as leaving CO2. Okay. Now NOx reduction by ammonia on catalyst. So, like some reactions I will write NH3 plus NO. NOx means any kind of X can be, where X equals to natural number. Like 1, 2, 3, any number, right? So these are called NOx, nitrogen oxide compounds. So NH3NO plus NO2 will give rise to N2 plus H2. Now for balance, 2NH3, 2N2, 3H2. Okay, similarly 4NH3 plus 2NO plus O2. This will give to 3N2 plus H2, 6H2. Okay. Then 4NH3 plus 4NO plus O2 4N2 plus 6H2. So our reaction is NH2 whole 2 CO and greater than 150 degrees C will give NH3. This consumed with NOx and some catalyst followed by generation of N2. So this was poisonous, right? NOx is being converted to some non-poisonous N2 stood by NH3. So this is the reaction. And several other kind of reactions also we can write, but these are the major reaction. Okay. So the major reactions. So that's it. So today we have discussed some nitrogen compounds like urea, along with that some potassium containing fertilizer, then some molecular weight calculation, carbonation process also, some mixed fertilizer like ammonium phosphate, and also some iodine containing hormone, and then the reaction of some iodine containing compounds, and after that alkali bromate production method, and some chlorinated important compounds like bleaching powder. So that's all for today. Thank you all.